Hi Manish. Okay then, so let's continue. I guess no one is going to join now. Okay, so in today's class, we're going to start with the new chapter that is the aldehyde, ketone, and carboxylic acid. Okay, I don't know about this, Manish. Okay, according to me, no. Okay, so that's it. So let's continue with the aldehyde, ketone, and carboxylic acid. This is going to be the new chapter. And if you have to compare the weightage between all the organic chapters, so this is the really important chapter there. So let's start with the chapter. So what is this? Carbonyl compound. Okay, so first of all, that carbonyl compound, if I'm using this word, the first thing strike in everyone mind that is this. Okay, what is it? It's a aldehyde, we know, right? So as the name of the chapter is also aldehyde. Okay, next one is what? That if you are observing something, this is a COR. Okay, what is it? It's a ketone group. It's a normally the ketone group. Or what if I'm using this? So what is it? Carboxylic acid, right? It's a carboxylic acid group. Okay, if I'm using R, CO, NH2, what is it? It's a amide group. Okay, it's a amide. If I'm using R, CO, R is there. So what is it? It's a ester group. If I'm using R, CO, Cl is there. Okay, so it's acyl group. Okay, so there's a so many carbonyl compound we are going to discuss in this session or in this chapter, you can say. So let's discuss how to classify the carbonyl compound into different classes. So first of all, what is carbonyl? Like this is the basic point that you will be having some R and CO is connected. And this can be changed. This Y can be changed. This Y can be H if aldehyde. This Y can be R if ketone. This Y can be OH if carboxylic acid. This Y can be NH2 if amide. Okay, this y can be o r if ester, or this y can be this if anhydride is there. So y can be anything there. This is for aliphatic system. This is the aliphatic system, or the system where we're not having any kind of aromatic system. And this side, this is a aromatic system. So it's aliphatic, it's aromatic. Okay, simple. This is a carbonyl compound. So we have to classify this is into the two class. The class number one, aldehyde. The class number two is the ketone there. So the carbonyl compound with the group that can't be replaced by any nucleophile. Okay, nucleophile be like, in this case, be noted. For example, what is the meaning of this statement here? That nucleophile one. Okay, let's suppose if you are having some R, CO, this kind of group, okay? So if some nucleophile is there, so be noted nucleophile every time attack here. Why it's every time attacking here? Because just because the partial negative charge on oxygen, partial positive charge on a carbon there. So be noted, it's not like that okay nucleophile come and replace this Y. No. Nucleophile always attack on the carbon. This is the point number one. It's not attacking on this Y. It's this is the point to be noted. So let's just back again what we're discussing here, that it can't be replaced by the nucleophile. Okay, so it's aldehyde or a ketone there. It means this R we can't H can't replace, or R we can't replace. But yes, if you are having acid or ester or ether, so yeah, you can go. Not sorry, did I say ether? Sorry, that carboxylic acid. So let's see the class number two, that when this Y can be anything. If this is OH, it's become carboxylic acid. So when carbonyl compound is with the group, that can be replaced by the nucleophile. So let me explain this point one more time. If this is H. Okay, the point number one, if this is aldehyde. So it means this hydrogen can't be replaced by the nucleophile. Or the point number two, this is a ketone. This R is not replaced by this nucleophile. But on the other hand, if let's suppose you are having this, okay, we discussed so many times, esterification type of reaction or any. Like this can be acid, or this can be amide, or this can be ester, or this can be anhydride, or this can be acyl chloride. Okay, so any group can be there. So in this case, chlorine can be replaced, OH can be replaced, NH2 can be replaced, or this complete part can be replaced. So this is the meaning two classes. The class number one, when this Y is not replaceable, like ketone or aldehyde, and the point number two, when both are this point is replaceable. So it's a class number two, basically you can say. Okay, so let's just back again. What is the class number two? So these are some example like ester, amide, acid chloride, anhydride, and carboxylic acid. Now the next point, that why we are dealing with this aldehyde, ketone, and carboxylic acid. Is this really important here? This is the starting only, okay? I guess your name is Navish, okay? So yes, this is just a starting. Halo alkane. Yes, already covered, okay? We already covered this halo, that what you are asking, halo alkane, halorine. Just check it the older video, okay? On the channel. So just go visit channel and then please list search for the playlist. There in a playlist we already covered that chapter. Okay? Yeah. So what we're discussing this. Now the next point is what is so special about this carbonyl family? So let's discuss some basic uses there. The point number one, that HCH is there. So everyone, I guess you know what is it? It's a, okay, let me just write it here. This thing. It's what? It's a formaldehyde. Okay? It's a formaldehyde. So anyone, do you know the use of formaldehyde? Formaldehyde. Have you ever visited in the biology lab? Formalin is a solution used to store in which we used to store the fossils, preservative, very good. Okay, so in this case, that it's a very good preservative. If some death, let's suppose some death, dead body or something there, we used to spray this so that that doesn't no smell from the body. So it's a very good preservative. It kill the bacteria, you can say. The second one, if you're observing here, the second use, that penicillin. Okay, ma'am, structure is so scary. Okay, don't need to remember the structure. Okay, simple is what this is penicillin. Important is what it's a carbonyl family. So what is penicillin? The you can say if you are go with in the antibiotics, so penicillin is one of the famous one, right? So penicillin is an antibiotic drug. It's discovered by the Alexander Fleming there. Okay, so you can say it's a very good drug. Okay. Next, look at the next picture here. What is this? This is a bloodhound. Okay, you know what is the use of this? Maybe you already observing in the movies, let's suppose a crime scene there, and then we're using bloodhound, and then this one sniff something, smell something, and then search for that particular person. But have you ever thought about this thing, that why? Okay. Yes, why? Do you know every person has a particular body odor? But why? What is the real meaning of that body odor? Ketone and aldehyde is responsible for the body odor of a particular person. Every person has a different body odor, like a fingerprinting DNA. Like every person has a different DNA and fingerprinting. Same we are observing here. Okay, so that's it. This is all for the case. Okay then. So, other uses? Yes, observe this. Okay, this is not important, the structure again. That is retinal. You know what is retinal? Retinal is a kind of, again, a chemical that present in our eye, that retina. Maybe in ninth or 10th class, you already know about the eye, that retina is there. Okay, ciliary muscle is there. Everything about the eye. Okay, so retina play a very much important role in our eye. Vitamin A is responsible for that retinal kind of pigment. Okay, so we are not biology students, so we are not going to follow in very detail. Okay, next please. So look at this. What is it? It's a cinnamon. Okay, in Hindi, it's dalchini. Okay, it's a kind of spice. Now, this is really important. This is really important. It's what? It's a cinemaldehyde. Okay, so this question asks so many time in a PYQ, that what is the structure of cinemaldehyde? So this is a kind of benzene. okay, and a carbon, and just after this you will be having a double bond. Okay, then again it's a COH group is there, so it's a cinemaldehyde. So it's really important how the question frame from this topic, that in cinemaldehyde, or like in that is a cinnamon, how many carbon is sp2 hybridized. So this is a structure, it is a cinemaldehyde. The common name is really 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 important here, okay? It's a cinemaldehyde. Okay, it's a cinemaldehyde, important. So put star, it's important one. Next one. So look at this. That is vanilla ice cream. You know, vanilla also has a kind of that you can say aldehyde. So what is it? It's a vanillin. So again, the common name is really important for this vanillin again. So just be noted every name which one we are I'm highlighting here. Okay. So the first one, cinemaldehyde. The second one is what? Vanillin. So what is vanillin? So this is a kind of benzene. Okay, it is connected with the COH group. Obviously, it's a aldehyde one. Okay, and this is the OCH3, and this is a OH there. So this is our vanillin. Common name is again important here. So it's a vanillin, vanilla ice cream. Important again. Next, look at the this one. What is it? It's a meadow sweet. Okay, spatially. Okay, maybe you already know this kind of flower, okay? So look at this. Again, it's important that the name is what? Salicylaldehyde. Salicylaldehyde we already covered. If you remember which reaction, what was the name of that reaction where we're preparing the salicylaldehyde? Yes, please, anyone? We already covered this topic earlier. Let me just write the structure. Which reaction? Don't know. So Reamer Timon is the reaction if you remember, okay? That we are using some kind of NUH there, and then what was that? That CHCl3 chloroform. Okay, carbene formation. We already covered this topic in very much detail there. So observe this, that again it's a kind of benzene. Okay, it is a COH and OH is there. So don't say ma'am and where there the OH is the first one. Okay, not an issue. Okay, you can do you can cover any point here. So again, it's what? It's a salicylaldehyde. So how many common name? Three common name: cinemaldehyde, vanillin, or the salicylaldehyde. Okay. Okay then. So that's it. So in short, if we are talking about the uses only, so what are the important uses for this carbonyl family? They are very good solvent, add in flavoring product. Okay, maybe you already know ester has a very sweet smell. We used to add in soap, solution, and anything. For pharmaceutical use, as we just observing, formalin, okay, preservative, and the next one is what? Penicillin is also important. Making perfume, obviously the good smell. Preparing paint and plastic and fabric as well, and a very good adhesive and the resins there. Okay, so this is a kind of use. So it means that carbonyl play a very much important role in our day-to-day life. Yes. Now the next topic, that let's discuss about the nomenclature. So first of all, IUPAC 1, then the common name. IUPAC 1, I'm not going to explain here, just a kind of brief only. We already covered in 11th class. In today's class, the important point is the common name only. Common name is really important here. Okay, some important common name. So first of all, let's take a quick recap that if you're using acetone, or if we are having acetone, so which is the prefix? Prefix is the oxo. Okay, or keto you can say. Suffix is on. I hope you know when we're using a suffix or when we use a prefix. Let me just write if you don't know. If you're having a kind of functional group, be noted. Okay. So if functional group is principal one, if our functional group is the principal functional group, so you know the principal functional group priority order wise. For example, if let's suppose I'm having COH group, or that is a CONH2 group. So the priority wise, that the acid has a maximum priority. Maybe you know the priority table. So this was present at the top one. So it means for this one I'm going to use the suffix. So the principal one, for the principal one we are using the suffix point. And what is the suffix for the carboxylic acid? That is oic acid is the suffix. Okay, and on the other hand, for the inferior one, or you can say if that this is not superior, so if it behave like a substituent part here, if behave like a substituent, so then we are using a prefix there. Okay, so this is a normal logic there. So let's just back again. Sorry, not this slide. Okay, back. So look at this. Suffix we are using if something being like a superior, otherwise go with the prefix. Aldehyde for more oxo, otherwise al, okay. For this one carbomolil, otherwise amide. And this one halocarbonyl or olehalite. And for this one oxycarbonyl and OH. And for this one directly oic anhydride. Okay, and for this one carboxy or oic is there. Don't worry, let's solve some question. Try to answer the question. Okay, then we have to go with the common name. So let's see, that is some name. Let's try to answer the question. The question number one. That, okay, let me just give the numbering. It is going to be the A. Okay, this is A, this is B, this is C, and this is D. So let's start. Yes, please. What is the name for the compound number one? I will write, okay? Wait. You have to solve the numbering, okay? Till then, sorry, answer the question. Till then, I have to write the priority word. Okay, so the priority one, that is the first priority is given to the acid, CH group. Okay, the second priority is given to the acid anhydride. This is the second priority group. Third, that ester, then amide, then nitrile. After this, anyone more left? RCN, okay. After this, amide nitrile, then aldehyde, and then ketone, and then alcohol, then a wine, then carbon double bond alkene, then carbon triple bond, and then carbon single bond. And make a not a kind of important point here. If you to go with the not, so ROR group, NO2 group, OH group, phenyl group, sorry, not OH, phenyl or halogen. So you have to treat it these like a substituent. This is not a special type of functional group kind of point. Okay, simple halogen, NO2 group, ROR group, or if phenyl is there, so you have to treat it them like a normal substituent only. Okay, so is this point clear, Navish? You are asking, right? And you, of course, you have to use, okay? If you're having, then why not? So yeah, what we're discussing the nomenclature, right? So yes, back there. So about the nomenclature, let's try to understand this point here. So look at this. In this case, the main point is what? This is the main point here. Ketone. Ketone is the main point here. Okay, so in this case, if you're to go with the numbering, so how about the numbering there? That the numbering starting from this one, two, three, four, or five. Okay, total this. So what is the name for this compound? So it's second position. So you can say, wait. It's a 2 at second position and fourth position. 2,4 dimethyl. Okay, 2,4 dimethyl, and it's become pentaone. Okay, pentaone. So this is the answer for this question. Okay, next, how about the this one? Okay, the C one here. So I hope you already know that in this case, which one is behaving like a the parent one, this one. The numbering starting from this 1, 2, 3, and 4. Okay, so it means this is being like a substituent now. So what is the name for this one? That you can say at second position you will be having methyl group. Look at this. So it's a 2 methyl and it and then 4 phenyl. 2 methyl, 4 phenyl, and then 4 is the carbon there. So it's, you can say it's a butanal there. So this is the name. 2 methyl, 4 phenyl, and butanal. This is the answer for this question. Okay, then how about this B is there? So in this case, which one is the parent again? This is the numbering starting from this. So it's a 1, 2, 3, 4, 5, and 6. Okay, so in this case, what is the name for the compound? That at third position you will be having methyl. So it's a 3 methyl, 3 methyl, and it's a cyclohexane, 3 methyl cyclohexane carbaldehyde. Okay, I hope you already know that is when this is not the part of the parent chain, that any functional group. So you have to use the carb word like carboxylic acid, or here we're using a carbaldehyde. So this is the name for the B there. How about the D there? Look at this, the D point again. In this case, the main chain is what? That 1, 2, 3, 4, and 5. Don't say, ma'am, this. Come on. Okay, the main chain is which chain in which we are having a maximum functional group. Means what I want to say, if let's suppose you are going with this, okay? Look at this, maybe it's not visible. Okay, if you have to go with this, so okay, it's a long chain, but what is the problem with this chain? That this one have only one functional group. So that's why we are not going to consider this as a the parent one. The parent one is what? 1, 2, 3, 4, and 5. It means that at third position, okay, at third position. Now then let's see the next point here. At third position, numbering be like 1, 2, 3, and 4. So I can say now that at three position. So what is the name for this compound? At three position, there is a butyl group. So three butyl, and there's a number, like five carbon is there. So it's become five pent. And at fourth position or two position, 2,4 dione is there. Okay, why? Because it's a ketone. Three butyl pant 2,4 dione. This is the name for the D there. So any issue with the nomenclature first of all? No, if you're using this cyclohexanaldehyde, okay, listen that Navish, what is the rule? Okay, wait, I will explain the rule that what I'm using in a B option. Okay, let's suppose this is a kind of cycle there, okay, cycle, and this is my CO. If you have to observe, like, let's suppose I'm giving the numbering here, okay, so I can't do this that this is a carbon number 1, 2, 3, and 4, and then 5, and then 6 or 7. It's a wrong. Either you can consider this is the single part, or this is a separate part. This is the only rule. So it means that the COH group is forcing, or the ring is forcing, be like, you can't take this is a carbon number 1. Means you have to simply take this is a like 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon, or 6 carbon. So what is the name? Like you have to answer this separately. This is my cyclohexane. This is cyclohexane, and now we have to answer this separately, that what is it. Now we are using the suffix that is carboxylic acid. This is the rule. If the main functional group is not the part of a parent chain, then we have to use carb, like carbaldehyde, okay, carbomonal, like here carboxylic acid. Okay, Navish, is this pen clear? That why you can't use 3-methyl cyclohexanaldehyde there? Okay, we have to use carb every time if this is not the part of a parent chain. Okay, then. So that's it. This is all for the nomenclature. And in very much detail, if you want to understand, just go with the 11th class again. Okay, then. So now answer some question. Question number one. That is, okay, let's just discuss this later. Okay, cinnamol one, answer this please. So if you are having a cinnamoldehyde, then how many carbon is sp2 hybridized? Cinnamoldehyde. Okay, so I already told you cinnamoldehyde is important. So answer this question, okay? Doubt classes. Okay, if you are having any particular doubt, then connect me with me separately, okay? Not an issue. Because of course I can't waste my time here just for one doubt class, okay? So don't, not an issue, just connect with me personally if your doubt is very huge or something. So we can arrange a meet, okay? Google Meet. Don't worry about this. Yes, please. Cinemaldehyde. How many carbon is sp2 hybridized? Okay, so we just start with the session. Not an issue. Let's just back again what is cinemaldehyde, right? So do we or not? You can go or not. 8? Okay, B. So what is cinemaldehyde? Okay, let's see what is cinemaldehyde. That it's a benzene. Okay, let me just write because we are going to check it for the number of carbon, right? So it's a benzene, and this is a C, carbon double bond, and this is a C which is there. This is a cinemaldehyde. We discussed, right? Let me just back again. Where's the cinemaldehyde, cinemaldehyde, cinemaldehyde? This. Okay, see this. See this, everyone. It's a cinemaldehyde. Okay, so let's just back again where we are discussing about the question. Okay, yes, please. So how many carbon? sp2 hybridized. So it's a sp2, it's a sp2, it's a sp2, it's a sp2, sp2. Okay, so better to highlight: one carbon, two carbon, three, four, five, six, seven, 8 and 9. Okay, so what is the correct answer for this question? C is the correct answer for this question. Okay, I hope this point is clear, right? Yes, Niharika. No, Niharika. That C is the correct answer. 9 is the number of carbon. Okay, so that's why here the common name play a very much important role. The cinnamon one and the salicyl one, or that vanillin. Three common names should be on your fingertips. Really, really, really very much important. Okay, let's quickly wrap up the common name part here. So let's discuss about the common name. IUPAC is enough. Now let's talk about the common name. Common be like that if you're not using proper nomenclature. Look at this. In this case, if you have to go with like one carbon, two carbon, three carbon, four carbon. So at three position there's a bromine. It's become butanol. It's a systematic naming. But if I want to give the common name, and it's not like only one you can follow. There's just so many different kind of way to find the common name. So look at this. For the common name, I'm assigning alpha and beta position. So this time I'm using that at beta position the bromine present, and instead of using butyl, we're using butyryl, okay, and then aldehyde is there. So it's a kind of common name for this. Let's see some other common name as well. Look at this. The first one is what? It's a vinylaldehyde. Okay? Like how many carbon is there? One carbon, two carbon, three carbon, four carbon, five carbon. If you're having a carbon connected with an aldehyde, so it's become vinylaldehyde. This is acrolein. It's not, maybe it's not that much important here, but it's a very really important for the polymer chemistry. Acrolein. Okay, maybe you already know, you know the pen, polyacrylonitrile. So pen. Where that okay, leave that. It's a environmental chemistry part. You maybe not covered that. Okay, look at this. That is the it's a phthalaldehyde there. Okay, so look at this. What is the phthalaldehyde? If let's suppose this is a benzene ring and at 1 and 2 position the CHO group is there. Okay, so it's a phthalaldehyde. Wait, I'm highlighting. Why I'm highlighting this? Wait. Like if you to cover side by side, if let's suppose it's a CHO and CHO. So what is it? It we just discuss about that is a thalal. And similarly, this one, okay? Okay, it's a thallaldehyde. But on the other hand, if I'm using two times COH and COH is there. So what does it become? It's a phthalic acid. Okay, it's become phthalic acid. But on the other hand, let's suppose if the CHO they are present at NT to one another. So now we have to use ter. Okay, ter at in the very start. So it's become terthalaldehyde. Okay, so it's become terthalaldehyde. And same. if both the CH group connected like this, COH and COH. So what is it's become? It's become ter. It's become terthalic acid, okay? Terthalic acid. So be noted again, both are the important part. Okay, so both is really important. So important aldehyde if aldehyde is there, phthalic acid if acid is there. So these two also important common name. Let's back again. This is simple, right? It's a meta. You know you can use numbering for the IUPAC. Otherwise you can go with the meta or like this. So again, look at this. It's a meta bromo benzaldehyde. Okay, why the benzaldehyde? Because in this case, CH has only one hydrogen. We already covered benzyl, benzo, or benzyl part already. Okay, so these are some very much important common name. Some you can search from the NCRT. Okay, this is all for the common nomenclature. Now let's solve that question which we just discussed there. Okay, answer this. How many CHO functional group present in a phthalate? Okay, I hope now you are able to answer this question. Please answer this. Yeah, Terra. Yes, of course, Niharika. Two. Come on. Like you mean to say two is the CHO group, right? Or option B. Okay, Vedant. Okay, that Navish. Okay, Niharika. So it means option C is the correct here, right? So yes, everyone you're right. What is the correct answer for this question? Wait. The correct answer for this question is that option number C there. We just discussed, right? How many CHO group is there? CHO or a CHO there? So two is the correct answer. Let's see the last point, some more common name, okay? After this, we are going to end the class. I know so much time, right? So let's see some common name. Again, we can compare side by side that this side acid or aldehyde, okay? So first of all, we are discussing about the common name, some important common name. Like if this is a COH. Okay, everyone I guess you already know. It's famous for the common name that is formic acid. Formic acid. Okay, similarly, this is a CHO. It's a formaldehyde. It's a formaldehyde. Next one, that it's a CH3COH. Okay, this is the basic class question, that acetic acid. Or it's present in what? That is vinegar. And similarly, that if I'm using CH3 and a CHO, so it's become acetaldehyde. Sorry, acetaldehyde. Okay, next one is what? If we are having a three carbon, so it's become prop, and then add is what? Propionic acid. It's a propionic acid. Similarly, that if I'm using three carbon here, CH3, CH2, and a CHO there, so it's become propionaldehyde. That's it. This is the important. It's a propionaldehyde. This is the only like class where the common name is that much important as the IUPAC one. Okay, so that's it. One more I have to write here, four carbon. Two CH3 group is there and a COH is there. So what is it? We discuss it's a iso group. It's a iso group. So what is the name for this one? It's a iso. Oh, sorry. It's a iso. And how many carbon is there? Four carbon. So instead of using butyl, we are using butyric. Like for the three, we are using propionic. So similarly, here we are using a butyric acid. So isobutyric acid is there. Same for aldehyde, isobutyldehyde. Okay then, let's see some more. Okay, this is next one. So what is it? It's become, this is a acetic group, two carbon, and it's a phenyl kind of group. So what is the name for this point? That is known as a acetophenone. So what is it? It's a acetophenone. Like phenone for this part and aceto for two carbon is the acetophenone. Next one more. If two benzene ring is connected with one another. Because now how the question frame that you are having acetophenone at this. So at least we have to know the structure of the acetophenone. How about this? For this one we are using that is benzo. One part is benzo and one is phenone. So it's a benzophenone. Like if you to observe, this carbon is not connected with any hydrogen, so that's why the benzophenone. So benzophenone, acetophenone important, and some common name be like this, and yes, phthalic acid one, and then cinnamon, vanillin, and butyryl. Okay, so these are the important. That's it. This is all for the nomenclature. In the next class, we are going to start with the preparation part. Okay, it's enough for the today's class. So if you're having any doubt or a problem, please ask. If you want to note it, so these are the kind of thing. Lowering the vapor pressure due to solute is 1 molar aqueous solution 100 degrees Celsius than the solute and another dissociation or association. Okay, I'm waiting, not an issue. You'll come. So thank you so much everyone then for joining the session. You can leave now. Okay, till then I'm explaining you a question now. So lowering with vapor pressure due to the solid is 1 mole at 100 degrees Celsius. That's it. But you identify the lowering vapor pressure. 1 mole is the solution, okay. I have to try, okay. So we are given with the 1 mole solution. 1 mole means you can say 1 mole of solute present in 1 kilogram of a solvent. So lowering of vapor pressure formula means you can say that is a sorry, P naught minus Ps divided by the P naught there is equal to that N of A divided by N of A plus N of B. There is some kind of molar mass is also given. This much information is given. Lowering your vapor pressure due to the solute one. How to solve then if mass is not given? Come on, we can't do this, okay? Not an issue. Okay, we are given with the mole, right? So we can solve. We can solve. I will try. Okay. So yes, that 1 mole solute. So Na means N is 1 mole. We can say. How about the water? So the number of mole of water is 1000 divided by 18. So we can say 5.55 there. Okay. So question asked about the torr. So the P naught is equal to 760 mm of Hg, or this is equal to 760 torr as well. So let's substitute the value here. It's a 760 minus PS divided by 760. 1 divided by, okay, 55 plus 1 if you have to add. So it's a 56.55 there. Okay, so let's solve this. Okay, so 760 divided by 56.55, 13 point something. Sorry, then. So, oh, wait. So you can say 760 minus PS is equal to 760 divided by 56.55. Okay, if I'm blocking your path, don't worry, I will change the position, okay? So when you to solve this, what will be the answer we are getting? It's 13.43. This much is torr. Okay, why? Because question asks the lowering in vapor pressure. So this is a lowering. PS by P naught is the lowering in vapor pressure. So this is lowering. So according to me, what will be the answer for the question? That option, I don't know the number, what is the correct one, but it's 13.44 is the correct answer, okay? Yes, of course. That torr is equal to mm of Hg. Both have the same thing. Okay? 760 because this is a atmospheric pressure. If nothing is mentioned, normally plain water is mentioned, always go with the 760. Okay? Navish? Okay. No, I'm asking like you are getting the solution or not. Definitely the answer is correct. Okay? Yeah, Vimal. I don't know. Anyway, so okay, Vimal, is this correct? At least you have to change your name, like Spice to Gaming. Okay, so I hope it's clear now. Okay, shall we end or still any more problem left? Okay, then. Thank you then. Thanks for joining the class. Okay, have a nice day, everyone. Thank you.